We're given these two functions, and we're going to go over the function algebra here. So you can see I've got one of each of the major functions, and then I'm also going to do a specific value, kind of make sure we know how to do all the pieces. And you'll see some of the homework problems are very similar to this. Okay, so I'm going to start here with the, easy ones for most of us, which is the addition. So you can see here, and I usually rewrite this way. I prefer this notation. So in both those cases, and I'm just doing both of them together here to make it easier, I prefer it looking this way because to me that more easily than I can see, oh, this goes here and this goes here, okay? So then I look down here and go, okay, negative 3x plus 5x squared. And this would be done right. These are unlike terms. There's nothing else I could do here. And then if I was going to put 0 into here, I could either do them separately, which is going to be 0, because negative 3 times 0 is 0, and there's going to be a 0. So if I did f of 0, I'm going to get 0, and g of 0 is 0. So this would be 0 plus 0. And I can see if I put a 0 into here, which is also, it's the same thing, 0 plus 0 equals 0. Okay? That one wasn't too bad, right? We're like, okay, I got that. Now we're going to move on to subtraction. Subtraction isn't much harder. It's just the big thing is remembering when you rewrite it that you have to be very, very careful of this negative sign. And usually when I put stuff in, I put in parentheses. And this one's only one term, not as big a deal. But it can be a really big deal even at one term with the subtraction because you got to make sure you get those signs in here. So then this is going to be negative 3x minus 5x squared, okay? So there's my g of x plugs in. And so you can see here then, this isn't going to go anywhere. I'm going to drop them there. But say had this been a negative, and those two negatives would have canceled out. So you need to be really cognizant of those negatives and make sure you don't make a mistake. Same thing before. Now I'm asked to, what am I putting in? Okay, I said f of 1. So I have f of 1 minus g of 1. Now addition is commutative, order won't matter. Subtraction is not, order does matter. So then f of 1 is negative 3 times 1, which is negative 3. And g of 1 is 5 times 1 squared, which is 5. So it'd be negative 3 plus 5, which is 2. And I can see the same thing here. If I put this in, I would get, oh, and I changed the sign, didn't I? See, and I was telling you. Okay, when I went back and did the other one, minus. So this is going to become a negative 8. So if I come back here, this is negative 3 minus a negative 5, which is going to give me the same place as there. Okay. So you can see I'm making mistakes too. Really easy to do that. Now, next is multiplication. So this is f of x times g of s. So in this case, this is negative 3x times 5x squared. I'm hoping I remembered those, negative 3x and 5x squared. Okay? It drives me nuts when it does this. It decides that it's more fun to like move it around on my page. Okay, so what do I do here? Well, this is exponent rules, right? These are two matching bases, so I'm going to add the exponents, and there's a 1 up here. So this is going to be negative 15x to the third. Okay. Now, what do I have up here? What did I get? I said negative 2. Okay. So if I did f of negative 2 times g of negative 2, so the other way is I could put it into here, right? So this would be negative 15 times negative 2 to the third, which is negative 15 times negative 8, which is going to be some positive big number. I could probably write it out, but I'm also going to just find my calculator. 15 times 8 is 120. Now, same thing here. I'm going to put f into negative 2, so this is 3 times negative 2, which gives me a positive 6. And then here, this is going to be 5 times negative 2 squared, which is 4 times 4, which is 5 times 4, which is 20. So then I would have 6 times 20, which is also 120. Okay? Now, next one. So last one here is f divided by g of x. This is f of x over g of x. So in this case, negative 3x over 5x squared. Same thing though before, this is our quotient rule of our exponents, right? So this is going to become negative 3 over 5x, because I would have 1 minus 2, which is negative 1, which means it stays in the denominator. And there's my answer. Now, let's see here. I put in 5. Okay, so let's come down here. So first one, I could do each of these. So f of 5 gives you negative 3 times 5, which is negative 15. And g of 5 gives me 5 times 5 squared, which is 125. So then this would be negative 15 over 125, and then I would reduce negative 3. 125 divided by 5 is 25. Okay, so then this would be my answer. I also, you can see here, so if I come up here and I put in 5 right there, I would get right to there. Okay, so hopefully this helps you walk through the steps of these. It's mainly getting familiar. These follow all the same rules you're used to. There's really very little new here. It's just applying what you know about function notation and applying it more generally to algebra so that I can manipulate them. So that if people are talking about different functions, especially longer functions in business and economics, no one wants to rewrite them. So they label them something and tell you what to do with them.